This is Sean Farrell, Vivian Muncie, and Brian Sunter, and we are modeling a chain reaction, specifically nuclear fission using uranium, barium, and krypton. First, a neutron is shot into uranium-235. The uranium then splits into barium-142 and krypton-92. The original neutron, as well as an additional one, continue on a path and hit other uranium in the nuclear reactor. This process takes off exponentially as one neutron comes into each uranium and two come out. Energy is obtained from this process as radiation in the form of heat. As you can see, we have an unbalanced chemical equation. The atomic weights do not add up. 92 and 142 is 234, which does not equal the original atomic weight of the uranium-235. This is where the heat is created. This heat can be harvested in a controlled setting, such as a nuclear power plant, or the energy can be uncontrolled, such as in a nuclear weapon.
Here we have the Unity scene editor screen where we have the original conditions for our simulation laid out. We currently have a lot of uranium atoms positioned all throughout the scene and a single neutron, which when the simulation starts, each will be given a random force in a random direction, which will determine their starting velocity and orientation. Whenever a neutron collides with one of these uranium atoms, the uranium atom is destroyed and replaced with a barium and krypton atom, which look like these. And whenever there is a collision, there will be a particle effect with these red particles emanating out. Each of these particles has an atomic weight proportional to its real atomic weight. For example, the uranium has a mass of 235, the neutron has a mass of 1, the krypton has a mass of 92, and the barium has a mass of 142. And these numbers are actually used in the Unity physics engine to determine how much energy is transferred in the new velocities of the particles upon collision. We have a custom physics material for each of the elements, which determine properties such as angular drag, static and dynamic friction. There's a setting called bounciness that determines how much energy is transferred when there's a collision. Whenever there is a collision, just a force is applied to all the particles within a certain radius in a random direction, which continues to speed up the reaction as more and more collisions take place. The simulation. So the simulation begins and each particle has a random force applied to it. As you can see, the uranium atoms have a much greater mass, so their speed is much slower than the smaller purple neutrons and the kryptons and baryums. Whenever you see the red particles emanating, that signifies that a collision between a neutron and uranium has taken place. Because neutrons are produced during each collision, the rate of collision will speed up as more and more collisions take place. Over time, the amount of uranium will continue to decrease until they've all been destroyed, and the amount of barium and krypton and neutrons will increase.